Is everyone ready? Let's get ready for chemistry! In chemistry, we often deal with numbers that are really big and really small. For example, the mass of an electron, 0.0000, I'm not going to read all of that. We don't really want to write this number out like this every time we have to write down the mass of an electron. We would rather put it in scientific notation. So your goal today is to master the art of taking a number and converting it back and forth between scientific notation and standard notation. To put a decimal number like this into scientific notation, we would need to move the decimal over and count how many times we move the decimal over to find the power of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. We had to move the decimal over 34 times. So to have a normal number here, we would have to multiply it by 10 to the 34. Because this is a very small number, we're actually dividing by 10 34 times. So your exponent is actually negative 34. If the number is small, your exponent should be negative. If the number is big, your exponent should be positive. Scientific notation is a number followed by a decimal, followed by the other numbers, followed by a times 10 raised to the some exponent. Now, if I didn't go cross-eyed, that should be the number I'm looking for here. So the mass of an electron is 9.109 times 10 to the negative 34 grams. Or the radius of an aluminum atom in meters. An aluminum atom is a very small thing, so you would expect its radius to be very small. I would go cross-eyed and I would start losing track of how many zeros there were if I had to write this number out. Instead, we're going to put it in scientific notation. So we're going to count. We want the decimal point to be there. One number and then a decimal, followed by the rest of the numbers. And we're going to count how many times we have to move the decimal over to get to that spot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We had to move the decimal place 12 spots, 12 zeros to get there. Now this is a small number, so we would have had to have divided by 1.25 by 10 12 times. So we're dividing, so that's a negative exponent. If you had to move the decimal to the right, your exponent should be negative. If you have to move the decimal to the left, your exponent should be positive. So the mass of an atom of aluminum is 1.25 times 10 to the negative 12 meters. What if you've got a big number? This is Avogadro's number. Avogadro's number is never reported like this. What we would do is we would have a number followed by a decimal, followed by the rest of the numbers, followed by times 10 raised to the number of places we had to move the decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. We had to move the decimal 23 places to get to where we wanted it, so it's times 10 raised to the 23. This is a really big number, so the power of 10 is positive. For small numbers, the power of 10 is negative. For big numbers, the power of 10 is positive. Planck's constant, 6.626 times 10 raised to the, this is a decimal number, so we would expect the power of 10 to be negative. And now we have to go figure out how many decimal points we had to move it to get to here, 6.626. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. And you would never have seen someone write the number like that. They would always simply write it in scientific notation to begin with. So you're going to have to get comfortable with the idea of scientific notation, because there are some numbers that you just can't express as a normal number. Furthermore, if your calculator decides that your number is too big and doesn't have enough room to display it, your calculator will automatically display the number in scientific notation. This is the number of oxygen molecules in one breath. It's a very large number. You wouldn't report it like this. You would convert it into scientific notation. You would just report that number. So it would be 1.2519 times 10 raised to the, it's a very large number, so the power of 10 should be positive. And now we need to figure out how many places we move the decimal over. 3, 6, 9, 12, 15, 18, 21, 22. We would have had to move the decimal place over 22 times to get the decimal here, where it's a regular number and then a decimal and then some more numbers. Give this one a try. Convert this one into scientific notation. Pause the video and see if you can work it out. We would want the decimal here, so it would be 1.254 times 10 raised to the decimal would have to move 3 places to get there, so it would be 1 times 10 to the negative 3. Give this one a try. See if you can convert this number into scientific notation. We would want the number to be 6.3492. We want the decimal to be here. The decimal starts here, and we need to move it 5 places to the right to get there. I'm sorry, 5 places to the left to get there. This is a very large number, so the power of 10 should be positive. You might think that this number could just be left alone. It doesn't have to be turned into scientific notation. But if you know anything about significant figures, you understand that there are some times where the number needs to be in scientific notation to properly express the correct number of significant figures. This is not one of those times, but let's do it anyway. You would have a 2, and then a decimal, and then a 0. You would have to move the decimal place over 2 places to the right to get it to where it belongs, so 2 times 10 to the negative 2. Try to convert this number into scientific notation. Pause the video and work out the problem. You would want the decimal place to be here when you're done, because it's always a non-zero number followed by a decimal point followed by the rest of the numbers. The decimal place starts here, and you would have to move it 3 places to the left to get it to where it belongs. So 9.224 times 10 to the 3. To really understand scientific notation, you need to be able to go forwards and backwards. So if you take a number that's written in scientific notation, can you turn it back into standard notation? Can you turn it back into a regular number? This is a positive exponent, so when I'm done, my number should be big. If I move the decimal over this way, That's a small number. That's the wrong direction. I need to move the decimal place over 4 spaces to the right because it's a positive exponent, so that I'll have a big number. So my decimal place is going to go this way. 1, 2, 3, 4. Now, if you put the decimal place there, you need to add in some placeholder zeros here. So let's look at that again. The decimal place is going to move 4 times. 1, 2. Now if you move it to the right again, 3, you're missing a digit there. You would need to add a 0. 4, then you would need to add another 0. So this number is 37,600. Move the decimal over 4 times to the right. For this number, the number will be small when we're done. It'll be a decimal number. We're going to move the decimal over to the left so that the number is small when we're done. We're going to move the decimal 3 times. 1, 2, 3. This is 4,280. That was clearly the wrong direction. So let's move it 1, 2, 3. We moved it too far, so we'll need to make sure that we add in some zeros as placeholders here. So your number would be 0.00428. Give this number a try. Try to convert this into standard notation. Pause the video and try to work out the problem. I'm going to start by writing down the problem. I'm going to give myself some space here. The decimal is going to move 1, 2, 3, 4, 5 places to the right, and I want the number to be big when I'm done. So this was apparently 113,000. Try this yourself. Try to convert this back into standard notation. Pause the video and see what you can do. We're going to move the decimal place 4 times, and when we're done, we had better have a small number because there's a negative power of 10. So 1, 2, 3, 4. So 0.000834. Now your calculator will do this for you too. Most scientific calculators can switch between scientific notation mode and float mode. So you're looking for flow and you're looking for psi. If you select scientific notation, every number you punch into the screen will show up in scientific notation when you press enter. If you put it into float mode, which is what it normally is, any number that you put in scientific notation, the calculator will try to turn it into a normal number. So you can use your calculator to convert back and forth between a regular number and scientific notation if you know what you're doing. To punch this into your calculator, you would do 8.34 EE -4. There's a button on your calculator, and it changes depending on what type of calculator you've got. It might be the EE key, it might be the EXP key, or it might be the times 10 to the n key. But most scientific calculators have one of these buttons. You just need to find it. And it stands for times 10 raised to the. So to punch this number into your calculator, all you would have to do is press 8.34 and then the power of 10 button and then -4. Students make mistakes. They punch it in as 8.34 times 10 EE -4. If you do that, your number will be an extra power of 10 greater because this times 10 is already folded into the EE key. You don't have to press 8.34 times EE -4 either. The times is folded into the key. So you're looking for the exponent key, and it stands for times 10 raised to the. And if you were paying attention to what I said just now, when you try to use your calculator to do calculations, you will get this correct. If you're not careful about how you punch the numbers into your calculator is going to do some funny things with order of operations, things that you're not really prepared for. All right, so that's the lesson on scientific notation, and I hope it was helpful.